All right, welcome to our presentation on argument mining in scientific discourse. Our group consists of Lilia, Amin, Jialiang, and me, Christoph, and we are supervised by Johannes Daxenberger. So let's get to the agenda. So first of all, we describe the project. So what is our motivation? What are the goals? And how did we split it up in work packages? Then we talk about the intermediate results of each of these work packages. Then we talk about the expected results, and then we show how it looks like in a small demonstration. So first of all, the state of the art, we base our project on the argument search project, which is a search engine as a platform for querying a certain topic in a specific language. With this query, documents are retrieved from external data collections, and they are afterwards classified with an argument mining model, which gives out the pro and con arguments sentence-wise in the documents, and they are ranked depending on the date and their relevance to the topic and presented to the user. Our goal is to build up on this current argument search implementation so that it works on larger and, most important, on scientific documents. For that matter, we retrieve documents from the Springer and the directory of open access journals using their APIs, and the focus is on scientific documents. We then run a classification to get out the relevant scientific arguments. And they should not be sentence-wise, but we want to have it in a bigger, in the optimal case, a document context. So we need to paragraph-wise extract the arguments and rank them based on their relevance to the topic. And afterwards, the results should be provided by a UI in which you can first query the data, the document collections, and then the classification results are displayed. So we divided our project in 3 parts. First of all, we need to retrieve the documents from the third-party APIs, and then we index them along in the pipeline using the UMA processing and Elasticsearch, and this is done with Java. The next task deals with the argument extraction. First of all, we want to have a baseline model and then do the paragraph-wise classification of the scientific arguments. And last but not least, we need to implement the demonstrator in subtask C, which is basically a UI where you can search the data collections using view.js, and the results are given out to the user.
Thank you. From here, I will show the architecture of the current project. So we had a base that we work on, which is the argument text. And in this argument text, we have the user puts his input here in the user interface, which is relevant for the demonstrator. And then the query is sent to the search API, which retrieves the document from data here from the subtask A. And the data is then classified using this model. Since we don't have access on the database of the argument mining API, we moved some methods to the demonstrator. Now Lilia will talk about.
Thank you, Amin. So as mentioned before, for task A, it's all about the data collections. We wanted to add the endpoints to implement Springer and to implement a directory of open access journals. At the moment, our current status is that we have a running service for querying Springer Nature. We chose the metadata API from Springer Nature, and this API delivers like most metadata we are interested in, and delivers as well a link to a body, so a PDF or PDF page or HTML page that we are crawling to retrieve the full content of the article that we are interested in. And here you can see an example of a response of our endpoint. This is a JSON response. The query in this case was lockdown. We can see that we have retrieved in total 3 records. These 3 records have metadata and have full content body. We have shorted out a little bit so that we make it more visible, but you can see in the metadata we have the title, we have the URL, we have the language, we extract the abstract as well, and yeah, this is an example output. Next slide. Okay, so the steps we went through during this data extraction from Springer were to, of course, like set up and explore what are the possible APIs we could implement to extract documents from Springer. And then we added Springer service as an endpoint to what we had already, to WIMA processing services. And we proceeded to process the input query that we received from Search API. So the user, when he enters a query to search for example, in the last example was about lockdown, we are going to interpret this to a query that is understandable by Springer and specify which documents we are interested in. In our case, we are interested in open access documents. And we also specify the number of results so that we do not get too many results that could make the performance worse of our service. And then we process the metadata response to only retrieve the metadata we were interested in. And then we parse the records for additional metadata. For example, we extracted from the records language and the URLs. The URLs were important because that's what we needed to extract the full body content from these documents. And so we had to check which URL is the correct one and which URL contains the right body. And we crawled for external data sources, starting from the URLs, and we used for that multi-threading for performance reasons. And so at the end, we parsed PDF and HTML data and retrieved the body content and added it to our JSON response. And then we sent this JSON response back to the classifier. So our next steps are to refactor a little bit to filter the records depending on the language that was used by that was set by the users. In our case, we can have data from any language because we detect the language from the body, but we want to have endpoints for English and German so that the argument search API allows for user to pick one of these 2 languages to query from. And we want to also allow user to have access to offline data, so work on the persistence of the retrieved documents to improve performance as well. And we want to add an endpoint for querying documents from, of course, a directory of open access journals, which is the second service we will implement. It will be similar to what we did for Springer, but the directory of open access journals provides URLs to different content, different websites, sometimes websites from schools, and I think the most interesting point will be to process these retrieved documents and to extract a meaningful body from them.
For task B, what we have done is that we are doing some experiments on open source review data to see how well the trust model performs on general augmentative data, and also do experiments on argument BERT API classifying query from task A. And we got our baseline model, and after some experience, and we got some results as well. The baseline model is mainly about classification on sentence level, and we are adding some heuristics to extract highly argumentative passages. Main pipeline for our classifier API is mainly, at first we need a pre-processing for text body. So we pre-process the JSON file from the output from task A generally, and clean the punctuation of text body and remove unnecessary strings. And finally, there is a sentence segmentation for sentence level classification. And then we load the pre-trained model and the fine-tuned model, for example, BERT or pre-trained Roberta. And we're using heuristic, for example, confidence ranking, argument density in passages, or some rule-based sentence level patterns to make the results more argumentative. And we evaluate the model and add some regularization to improve the model. The baseline model is called BERT Tiny. It's a quite small model with 2 transformer blocks and 128 hidden states. The results would be shown below with topic lockdown. We got the pro arguments. This has the benefit of minimizing the challenge on the intensive care unit capacity, but may well increase the economic damage. And the con argument would be showed as well. With current model, we are about to improve the heuristic for baseline model and to establish test sites for evaluation, and we also need to improve pre-processing. Furthermore, for our future works, we also need to do more experiments on BERT variants, on research article domains, and train model on multi-sentence or passage level. Prepare a training set for that matter, evaluate and compare the results to the baseline model. That's all for DASP.
So, okay, for the demonstrator, the current status is that there have no changes been made for the front end, and for the back end, we have built the interface that manages the communication between the surfaces. So kind of we took the role of the argument mining API a little bit. So in more details, we have added a method to direct the query from the user input to the Spring API through task A, and then we needed to adapt that response that we get and in a way that the API of the classifier understands, and we get the pros and contras, and then we add some more metadata such as URL and the source and number of documents and such things to those arguments that we retrieved. In the next steps, we need to add a filter so we can filter the results using the date, because all the results might be not very relevant anymore, and we need to use API from previous tasks. So there's a big dependency between task C and task B.
Now about the expected results for the whole project. We wanted to add access to offline data that is indexed with Elasticsearch because that would improve the performance greatly. If one user executes, for example, the same search twice, then we do not need to query and crawl these online documents twice, then we can use persisted data. And then we need to add as well the running service for GUAJ, so Directory of Open Access journals. And yeah, we want to extend the model to do a paragraph level classification, which would improve the relevance of the arguments that are classified and extracted from the documents. And then for the user interface, we plan on having these paragraph level arguments displayed as sentences that are within a context. Yeah, and now we will show you the demo of what we have achieved.
Now that we have our services running locally, we need to pick a scientific word, for example, lockdown, and this query will go through all the tasks that we've discussed, and we have also limited the number of documents retrieved to 3, because else it will last forever. And here are the retrieved arguments and their respective documents. Here we can see gone, for example, therefore we might lose visibility of users who are stationary for a long time or who do not use a given app for an extended period of time during lockdown. To make sure that we have retrieved the documents from scientific pages, we just need to search for it by word, for example, and yeah, we can find it from this document. We can also see like the documents that were retrieved and every argument according to which document. That's it from our part. Thank you for your attention, and we're ready to answer your questions.